Hello, my name is Jaime D'Anna, Head of Tech Partner Marketing at Neo4j, the recognized leader in graph technology, providing today's organizations with the data connectivity and ultimately insight they need. In this presentation entitled Neo4j Aura on Google Cloud, your key to unlocking insight in manufacturing, we'll be speaking about the manufacturing industry and supply chain processes, as well as give you insight into how customers on the Google Cloud are using Neo4j Aura, the graph database as a service, in the context of their most pervasive data challenges. Cloud has undoubtedly transformed manufacturing. According to the 2021 Modern Manufacturing Report, 66% of manufacturing enterprises from 17 countries reported some cloud deployment, and cloud-hosted services are expected to account for nearly half of all organization-level software usage among manufacturers by 2023. According to Information Week, lower costs and enhanced scalability were the biggest drivers for cloud adoption, and cloud-native applications allow access to the latest technology and talent, enabling adopters to build transaction processing systems capable of supporting very high volumes and low latency. Neo4j has a successful track record in resolving challenges across industries, but let's start off with the three most pervasive and common challenges we see in the manufacturing sector, also validated by TechTarget. At the top, we see a very persistent challenge being the lack of necessary collaboration needed throughout the supply chain, which are themselves becoming more and more complex. This complexity is growing alongside customer and technical pressures, but according to a study by PwC, the biggest hurdle is basic human nature and mistrust, even between departments of the same manufacturer, which impede building solid relationships and thus keeps this collaboration elusive. This mistrust throughout the supply chain often comes down to unanswered questions pertaining to data ownership, which risks data quality. An example would be a customer master held and administered by IT, where the record of John Smith, the client, is perceived as untouchable. Yet in the same organization, we have John R. Smith, located in a CRM system owned by line of business. This lack of collaboration and data from legacy systems can result in duplicate, disparate, and conflicting records. But despite these risks, many teams go along with the modus operandi, hiding behind certifications on systems, compliance initiatives, and things of that nature. But the reality is a lot of times it comes down to the fear of efficiency. Supply chain partners and manufacturers have this fear that once implemented, if costs drop from streamlined processes and added efficiencies, customers will expect and demand that these savings be passed along to them in the form of price reduction, which of course would eat further into narrowing profit margins. Digital transformation initiatives have many positive results, especially when relying on AI and automation. But in manufacturing, the net result is typically do more with less of everything. And oftentimes, this transparency in data usage and supply chain processes become the victims. Trucks or shipments delayed to inspections or unforeseen maintenance issues can cause backlogs in production or any number of negative consequences, namely damaged relationships among customers and suppliers. Lack of transparency or real-time updates means the inability to predict or foresee issues in time for a backup plan to remediate them before they create negative results. And the same lack of transparency between processes can be applied to the financial side of the house, which seeks to protect the organization from bad actors that can cost manufacturers large sums in credit or warranty fraud. Although the true size of warranty fraud is unknown, the trade publication Warranty Week estimates it at a high of 10% of warranty expenses, or 2 to 4% of company revenues annually, with the total warranty expense by US-based companies around $2.61 billion annually. Another of these top concerns is the exponentially high expectations today's customers have for every transaction. Think of the most used app on your smartphone. Maybe it's a social media app, maybe it's your favorite game. That's the bar by which every app is being measured against. One effect of the COVID economy is the trend towards more customers opting for digital interactions due to the decrease in ability to have in-person interactions, which creates a tech-savvy customer base that expects a personalized, predictable experience every time they interact digitally. Latency has always been a key consideration for financial trading, but a recent Computer Week study showed that every organization should ensure their latency is at 10 milliseconds or less. since Google has shown that over half of customers will literally start abandoning sites and apps that take over 3 seconds to load. Finally, real-time data coming from the customer is essential for building that feedback loop, which allows you to innovate and anticipate changes in the market or customer behaviors before your competitors. The negative impact of these challenges can be as detrimental to the bottom line as they can be complex. The importance of data quality can never be overstressed, specifically because a decrease in data quality can lead directly to an increase in risk and cost, which brings us to the topic of fraud. As an example, the LexisNexis Risk Solutions 2020 True Cost of Fraud study identified that the cost due to fraud in today's enterprise rose 12.8% from 2019 to 2020. And identity fraud made up the highest contributor to those losses at around 20%, attributing much of that to the increased digital activity from COVID. These types of crimes from bad actors affect the bottom line, both in the remediation of these crimes as well as in the loss of customers and even potentially suppliers due to the decrease in confidence in your organization's brand. This can also negatively affect the favorable credit terms both on suppliers and financial backers. Add to this the complexity of international business. As of 2020, there were over 200 legislations among 120 countries pertaining to data privacy, making compliance a moving target. Losses in the form of fines due to not adhering to specific operational regulations in a particular geo are a constant concern. And blind spots in the customer journey often result in dissatisfaction, which ultimately leads to churn. Without gaining the essential insight from your customers, there's no room to innovate and iterate on what they are looking for in your products and services for the next generation. And this translates to losing market share or even a competitive advantage. Graph is the fastest growing segment in database management systems. In fact, this Gartner quote from their top 10 trends report underscores the need and future-proof viability of graph technology. One of the key differentiators that makes graph technology the superior choice to meet the challenges in manufacturing we just described is the fact that in this architecture, the relationships between the data points are as important as the data points themselves. Other SQL-based data management tools rely on joins between tables that create a computing and memory burden, which becomes more unwieldy depending on the size and complexity of the query. In other words, these types of databases simply do not store or query relationships effectively. Back to our John Smith example, who, as it happens, approaches Acme X, a supplier of widgets, with an immediate request for a substantial volume asking for 60-day terms. While nobody at Acme X is actually any record or history with John R. Smith, specifically his company John R. Smith Holdings, they built an application on graph technology which now understands that there are several well-known entities now owned by John Smith Holdings and also identifies several well-known board members who also have prior requests from Acme X. They now understand that John R. Smith is in fact not John Smith, who previously attempted a request of widgets for his holding company, which has a long history of bad credit and fraudulent activity. The architecture, as well as the ability to share data with other SQL-based sources, such as BI tools, data lakes, or any host of applications, give manufacturing organizations that ability to collaborate across teams, automate processes, and provide that transparency to improve efficiencies as well as insight to engage with customers and suppliers. With that, I want to reiterate and drive home the fact that Neo4j is not only the recognized leader in graph database technology, but fully integrated with Google Cloud. There are, of course, many data management tools available, in fact, several options from Google specifically, but as you can see here from this chart, Neo4j fits a very specific need in Google's portfolio as they have no GraphDB technology. It is precisely for this reason that Neo4j and Google have invested heavily in our partnership and mutual product direction. You can find and deploy Neo4j Graph Database straight from the Google Marketplace, whether you want to use our virtual image of the Enterprise Edition or our cloud-native solution, Aura, the Graph Database as a Service. In any deployment, you are getting the same enterprise-grade scalability, reliability, and connectivity, along with the successful, repeatable use cases you can rely on to resolve your particular challenges in manufacturing. Let's take a moment to dive into the basics of a graph database model in the context of manufacturing. So graph databases are comprised of three elements. First, we have nodes, which are objects and represented here as the three circles, which can be labeled or tagged for classification purposes. In this case, two types, either person or car. Next, we have properties, which are simply key value pairs. So name equals Pat, born equals date of May 29, 1970, Twitter equals, etc. On the right is another node, property Chris, born equals December 5th, 1975. The Twitter property is blank, and unlike a standard SQL-based relational database where every row has an equal number of values and you have to stick to a no value there, these fields can absolutely be blank with no performance or logic issues. And finally, the power in graph technology is it combines these nodes and their properties with relationships. So as you can see, Pat loves Chris, Chris loves Pat, and both live with each other and have different relationships with the car. When you chart this graph out, you can see the directions of these relationships, which can be important in some instances and not necessarily in others. We see from left to right that Pat loves Chris. Then we see that Chris loves Pat. Now, that same relationship from Chris to Pat could have easily been tolerates instead of loves. Another relationship from left to right is lives with. Now, we only see it once here, since logically it would be impossible for Pat to live with Chris without Chris living with Pat, so we economize there. Notice we can also have properties on the relationships themselves, such as Pat's drives relationship, where the property equals date of January 10, 2011. So nodes, properties, and relationships actually give us everything we need to create rich and compelling data sets that can then be queried to gain insights. Next, I wanted to provide an example of the types of data found in a typical manufacturing company. First, we have the organizational data, which is internal to your company, such as documentation, like SOPs or any other corporate documents. Then there's data about your processes, data about your employees and physical assets, chairs, boardrooms, etc. An organizational hierarchy, KPIs and reports, and your IT infrastructure, systems, databases, and whatnot. And unfortunately, we spoke about earlier, these data sources and processes are often very siloed and not at all transparent. Next, we have data pertaining to products and services, including any documentation like specs, warranty info, as well as processes specific to these products. Also, the details about different products, a product hierarchy, brand, product line, or versions, and bills of materials related to your products. There could be different types of bills of materials, for example, manufacturing, engineering, configurable. You may also want to store different snapshots of a bill of materials, the generic design, a bill of materials for a product as built, and iterations of that as it's been repaired or upgraded over time. Then there's all the data you have on your customers, whether they are corporate or individual, which could include address, personal data, and documents related to them, such as contracts. You might also have information about relationships between your customers, either between individuals or between individuals and companies. And per the previous snapshot, this data may reside in different systems, like the customer master or a CRM, or they could potentially be centralized. Moving down, we see third-party data coming from outside, like social media data, market data, press releases, news stories, or surveys. Then we have data about specific events. This could include sensor or telematic data, which is growing exponentially due to all the IoT devices giving off signals. Events can also include individual claims and customer contacts, such as interactions with a call center through phone, email, or online chat. And finally, we have supply chain data, which could be information about your suppliers, whether raw materials, parts, or services. Logistics data, how long or how fast these items get from their place of origin to you or whatever final destination. And this would also include inventory data, that which is currently in stock or needed, or even time sensitive, as in on the verge of spoiling. So this list of data categories is not meant to be exhaustive by any nature, but rather to give you a sense of the complexity and thought that goes into these models. Now, let's start with supply chain, where we'll take a look at ways to combine the data just as we spoke about, to make the best decisions on how to manage your supply chain with the optimum transparency and use of relationships. In the yellow on the right, we have the information of our suppliers. In the green nodes, we have the components they supply us. We also see the cost and the options we have for shipping. We have inventory, existing inventory in facility A and B. We see that there are two separate components because of nomenclature, but in this case, coming from a different supplier. Yet we understand that functionally, it's the same and can be used interchangeably. Then moving left, we have the basics of a bill of materials, where we see assembly, which would obviously be much more complex than a real functional bill of materials. But here we see the relationships between how many orders contain these components, as well as the products that have already been sold that contain them. Ultimately, this gives us a view into how the supplier affects the finished products on order or sold. From this data, we could query forecasts, current sales, and this would give us insight into purchasing said components in a timely manner to ensure production and fulfillment is on target. Understanding the data points and the relationships between them can drastically accelerate procurement by automating manual, error-prone processes, providing further visibility from the demand to the supply and every point in between to anticipate and compensate for any potential delays. Leveraging economies of scale, such as getting the long-term view so that you can order in larger volumes with better discounts, and understanding where bottlenecks are likely to occur in order to remediate them and improve production to get you to market faster and widen your margins. Improved logistics means having parts accessible based on anticipated need, so you don't have to buy from zero based on the-spot requirements. This also reduces any potential spoilage of parts, components, or final products with a shelf life, procuring and using only what you need. Lastly, applying analytics allows you to compare parts and vendors against warranty data, failure, and negative reviews, so you can conduct cost analysis to see if getting the cheapest widget in the market gets you to your forecasted revenue when you account for the potential tariffs, returns, and other associated events. In essence, it gives you the insight to make the informed decisions about which suppliers and parts you want to work with. Earlier, we detailed the magnitude of cost associated with fraud, which is why today's forward-looking organizations are seeking to apply analytics to their warranty strategy to reduce risk, as well as ensure customer and supplier information is always up to date, contextual, and discoverable. Looking at this model, we see at the heart is the event data relating to the claim. The claim can quickly be associated to a particular part or component associated with a fault. We can then conduct further analysis to see how many times such a claim occurs involving specific parts or components due to the same fault. Then we can begin to understand that if that particular part is faulty due to the amount of claims in a span of time that are being brought, and even make some predictions as to how many future fail events are likely to occur in products made with that part or component. The tie-in to the previous slide is we can also take a look at the supplier of those parts, which seems to have patterns for the most incidents of failure, as they have relationships associated, in which case the cost of the warranty may be mitigated and passed along to the supplier of that part. We can also drill down and ascertain if there are any outliers in which these claims based on geography, number of events, etc., might give us a profile of fraudulent activity. We also get a holistic view of the finished products themselves, so we can see the history of repairs, the number of touch points, and other events. And one final relevant component here is social media. As we know, it is extremely important to brands in today's economy. Consumer Affairs Analysis states that when customers are unhappy, there's a 91% chance they won't do business with a company again, while dissatisfied customers typically tell 9 to 15 other people about their negative experiences and are likely to leave negative reviews on social media. So real-time analysis of this social media data is not only protecting your brand, but it also helps you to potentially influence the conversation before it goes into a negative direction. Neo4j has a very successful track record of applications built on graph technology to detect fraud. Graph enables you to quickly detect repeatable patterns, such as inappropriate claims, as they are coming from a specific buyer's persona, geography, or a claim that is taking on a particular characteristic, such as falsified documentation, constant delays, etc. These patterns can be applied against future purchases, which can add a score to measure the risk with a trigger if it falls above a specific threshold, and thus anticipate the potential for future claims. These same triggers, such as if 10 part failures happen in the same batch or shipment in a particular geography, can be used to kick off a workflow and cost analysis of the number of potential people affected to ascertain if a recall should take place, while at the same time alerting engineering that a fix or supply change is needed before the next production schedule. And lastly, isolating the parts of components that cause the failure against the entirety of the production process, the bill of materials, the assemblers, and transport environments, etc., allows manufacturers to potentially mitigate the costs of the warranty by passing them on to the suppliers, shippers, or whoever is ultimately responsible for the failure. And the last example we'll go into is Customer 360, which gathers data from various sources, as well as contextualizes it through the relationships to provide a complete profile. At the heart of the graph is the customer, and we can see additional relationships to other customers, such as employees, family members, etc. We have contract information and information not only about their current purchase, but their entire purchase history. Every event, such as a warranty claim, preferences, calls into support, points of sale, etc. And from this, we can begin to build a persona for this buyer to give a more personalized experience with every interaction. We can then utilize additional analytics to understand this customer's buying cycle, knowing that this customer is likely to purchase additional products based on their profile, and can then target the customer with the appropriate marketing activity in a timely manner to guide them into that purchase. And again, we see the social media activity here as well, which is extremely important to Customer 360 because the customer social media presence gives us a window into a number of key data points. Is this customer very active? Does this customer have very few or an exponentially high number of followers to the point of being an influencer? Do the customer's comments denote a high satisfaction with the product and brand to the point of possibly recommending it to the customer's network? All of this builds a more complete customer profile and improves your visibility not only with this customer, but also those connected by relationships. So a quick recap. Personalization is a key expectation for today's customers. Gathering data points such as how the customer prefers to interface with you over chat, text, through an app, on the phone, or in person, as well as how often the customer has interacted or purchased from you in the past, allows you to make every subsequent interaction or touch point with the customer a personalized experience and meets the high expectation of today's buyers. With the additional historical data, graph technology facilitates easy queries to identify high lifetime value customers that can be targeted for specific offers, loyalty programs, and higher touch sales engagements. Graph technology also allows you to score satisfaction levels based on these events, such as number of calls to support, negative social media posts, etc., so you can proactively remediate and avoid churn. And finally, understanding the customer allows you to upsell and cross-sell, not only to that customer, but as mentioned, to the customer's wider network. We have a number of manufacturing use cases based on repeatable success with graph technology, Volvo, US Army, and NASA, to name a few. We invite you to explore them on our website at neo4j.com. To close, we have an immense amount of resources for you to get started with Neo4j Aura on Google Cloud in your organization. You shouldn't have to reinvent the wheel when it comes to resolving any of the manufacturing challenges we spoke about here. As an example, we have a quick guide that allows you to build a recommendation engine similar to what we would use in the Customer 360 example we spoke about earlier. At the link provided on the screen, you'll find a video tutorial allowing you to follow along with other resources provided, literally a copy and paste exercise if you so desire. And point being, in minutes, you will be up and running with your first graph database on Aura. It's that easy. Again, you can also visit us on our website at neo4j.com, or more specifically at the link you see here, where you find valuable information on Neo4j Aura on Google Cloud. Thank you for joining us, and we hope to hear from you soon.